This is a video on dividing a polynomial by a monomial. And you might have seen this before. I'm just going to do a small example just to give you an idea of how to think about it. If I asked you to simplify something in this form, 12x plus 8 divided by 4. The 12x plus 8 you may have seen almost in a y equals mx plus b type form of a line. But if I'm dividing by 4 here, I'm dividing a polynomial, something with multiple terms, by a single term, monomial. And the way we've divided this, really what you can do is you can take each term of the numerator and put it over the monomial denominator. So 12x over 4 plus 8 over 4. Now you can only do this if there's one term in the denominator, but a monomial is one term, so this will be the easiest way to divide it. When we divide this, now we simplify like we normally would for fractions. So 12 divided by 4 would give me 3, and the x will just stay. Plus 8 divided by 4, we get 2, so we get 3x plus 2. Now the reason this works really is that, when you add fractions, or subtract for that matter, you find a common denominator and then you add through the numerator and keep the denominator the same. So that's how you ended up here. We're kind of undoing that process. We're putting each term over whatever that common denominator would have been, and then we're simplifying each term down. And that's basically how we're going to divide our polynomials by monomials, except for our denominators may contain variables now. We'll do a few more examples. So the directions here say divide. You may see perform indicated operation. You should know if you see a fraction that means division. But if I had 6x squared minus 15x plus 8, and I'm dividing this whole thing by 3x. So it's a polynomial divided by a monomial, a single term here in the denominator. So what we're allowed to do is take each term and put it over the denominator of 3x. So we'll have 6x squared over 3x minus 15x over 3x plus 8 over 3x. And then we just want to simplify this. So to remember to simplify, you're going to divide the same the coefficients of the coefficients and the same variables with the same base by the same variables with the same base. So here I have 6 divided by 3 will give me 2. X squared divided by x. Remember, when you divide, you subtract the exponents if you have the same base. So 2 minus this is really an exponent of 1 makes this x to the first power. You can almost think of that as like canceling one of them out if you'd like. Here we have minus 15 divided by 3 will give me 5. X divided by x really cancels out, right? When you have the same thing in the numerator and denominator of a fraction, if you have those same factors, you cancel them out with each other to a 1, which really just makes this minus 5 times 1, which is minus 5. So you can think of these x's as canceling if you want. Or you could use the rule for exponents, x to the 1 divided by x to the 1 be 1 minus 1, the x to the 0, which also equals 1. Plus, here we got 8 divided by 3x. And since 8 doesn't divide by 3 evenly and they don't share any common factor than 1, I'm going to leave them right where they are. I'm going to keep that x in the denominator. There were no pieces to be divided by that x, so I'm going to leave it right there. So essentially what we do is we divide term by term, and that's it. At the end of this, you should have individual terms. You don't want to put this whole thing over 3x, right? That was the whole point of dividing this, so we would get, individual terms. We'll do a couple more. I said to divide negative 15m to the third power minus 6m squared plus 20, all divided by negative 5m to the third power. Again, the first thing you should recognize is that we have a polynomial, something with multiple terms, divided by a single term, a monomial. So we can take each term and divide it by that monomial denominator. So we got negative 15m to the third divided by negative 5m to the third. We have minus This is 6m squared divided by negative 5m to the third. We have plus 20 divided by negative 5m to the third. And as we do these divisions in here, you want to make sure you pay attention to the signs that you get. So in this first one, a negative divided by a negative we know should come out positive. So we have that, and then negative 15 divided by negative 5, that'll give us a positive 3. Here, m to the third divided by m to the third, those cancel out because they're exactly the same. So we just have 3. For the second term, we have negative in front divided by a negative, so negative divided by a negative makes us a plus. All right, so we're handling this based on our division rules. And then we'll look at the coefficients. 6 divided by 5 doesn't reduce, so I'm going to keep that as 6 over 5. M squared divided by m to the third. When you divide things with the same base, you subtract their exponents. This should be m to the negative 1. Now, it's important to recognize this m is written right next to this fraction. You can consider it to be in the numerator when you do this operation. And then later on, we'll talk about how it might move to the denominator. But any division you do will be in the numerator until you move it. And then this last one, we have a positive divided by a negative makes this negative. And then when I see this as 20 over 5, I know that's 4. And since I didn't divide anything by the m cubed stays in the denominator. You keep it where it is because you didn't use it at all. So it hasn't been affected at all by the numerator. It stays in the denominator. Now once I'm at this point, I want to simplify so I only have positive exponents. So 3 stays 3. Plus, now here, 6/5 is still 6/5. The negative 1 on the m only applies to the m. It does not apply to the 6/5, so don't flip this fraction. Don't take the reciprocal. It's still going to be 6 over 5. The m to the negative 1, the negative tells you to move it to the denominator of the fraction and make the exponent positive. So it's 6 over 5m. And then minus here, 4 over m to the third just stays as it is. All right, you're just subtracting off that term. Make sure you keep these as individual terms here, and that's all you can do with this. You have only positive exponents in your final answer, and that's why we had to rewrite the m to the negative 1. Sometimes you can recognize that this m is going to be in the denominator at the end of the problem. Right at the very beginning, if you see that you have m squared divided by m to the third, you can see, okay, 2 of them are here, there's 3 of them here, so 2 of them cancel with 2 of them here, there's going to be 1 left in the bottom. If you do that and you have that left in the denominator, that's okay, but recognize you can only do this if the exponents are positive when you look at it in the original problem. And let's take a look at just a couple more. Said to divide 3y to the fourth minus 5y cubed plus 6y squared minus 9 over negative 3y. Again, you have a polynomial divided by a monomial. So taking a look at this, you have 3y to the fourth over negative 3y minus 5y to the third over negative 3y plus 6y squared divided by negative 3y, and then negative 9 divided by negative 3y. And now we'll evaluate this. Paying attention to the signs as you do this. 3 divided by a negative 3 will be a negative 1, and then y to the fourth divided by y makes us negative 1y to the third, which you don't need to write the 1 there, right? It's just negative y to the third. On the second term, we have a negative divided by a negative, which makes it positive. 5 divided by 3 doesn't reduce at all, so you kind of keep it as 5 over 3. The y to the third divided by y, remember you're subtracting the exponents 3 minus 1, so this is y to the second power. Again, this can be written in the numerator right next to it, but not in the denominator. The next term, we have a positive divided by a negative, so I know it's going to be negative. 6 divided by 3 will give me 2. Y squared divided by y, 2 minus 1 for the exponents makes us y to the first power, so it's minus 2y. And then the last term, a negative divided by a negative makes us a positive. 9 divided by 3 gives me 3. Since I didn't use the y at all, it's going to stay where it was, staying in the denominator. And since there are no negative exponents, we can leave everything just as is. All right, and we'll just take a look at one more. If I said to divide 2x to the fourth power minus 5x to the third power plus 8x squared all over 4x to the fifth power. So again, you should recognize you have a polynomial divided by a monomial. So this will be 2x to the fourth over 4x to the fifth, because we're just going to divide term by term, minus 5x to the third over 4x to the fifth, and plus 8x squared divided by 4x to the fifth. And I would definitely write this step. Sometimes people try to cancel as they're doing it. It really does not work very well because you might not be dividing by the same thing in each term. So divide each term individually and then simplify. Now be careful here. 2 divided by 4, that's 1/2 is what it reduces to. It's not, 2, right? Because 2 divided by 4, you're taking out a factor of 2 from each of these. You end up with 1 over 2, so it's 1/2. You have x to the fourth divided by x to the fifth. When you divide these, the same base, remember you subtract the exponents. 4 minus 5 gives you x to the negative 1. Remember that's right next to it or in the numerator when you perform the operation. We worry about moving it around later. Here we've got a negative, so minus 5 over 4. That does not reduce, so you keep it as 5 over 4. And then x to the third over x to the fifth will be x to the 3 minus 5, which is negative 2 power. And then plus 8 divided by 4. Now that will be 2 because, factoring out a 4 from the numerator and denominator, that reduces to 2 over 1, which is 2. X squared divided by x to the fifth is x to the negative 3, right? 2 minus 5 gives you negative 3. And now lastly, you just want to simplify this, making sure that your answer only has positive exponents in each term. So when I have 1/2 x to the negative 1, remember that negative exponent tells you to move it to the denominator and make the exponent positive. So you end up with 1 over 2 stays 2 in the denominator. The x gets written right next to it because it's moved down to the bottom of the fraction. Minus, we have 5/4 times x to the negative 2. The negative in the exponent tells you to move it down to the bottom. The 5/4 stays 5/4, right? Just like the 1/2 stayed 1/2 here. You don't move the 5/4, so it stays 5 over 4, and then the x to the negative 2 tells you the x moves to the denominator, the positive exponent of 2. Plus, in this last term, we got 2x to the negative 3. Remember, the negative 3 only applies to the x, not the 2. So this 2 is considered to be in the numerator. The only thing that moves to the denominator is this variable of x, and you make the exponent positive, so it'll be x to the third. And then you have it. Remember, at the end of these problems, you want individual terms. You don't want to write this all as one big fraction again. That's a common mistake people make. We're trying to have individual terms, and we do once we simplify it. So I hope this video helped. Thank you for watching.